Morning class. So welcome to this class today. For today's class we are having electrical principles. Our lesson title is use the concepts of DC and AC circuits in electrical installation. So our first section, our objectives, we are going to deal with identifying the basic SI units and also identifying the quantities of charge, force, work and power. So just to proceed to the main point, we normally have two main types of units. That is the SI units, the basic SI units, and the derived units. For the basic SI units, we normally define them as the fundamental units of measurements, and examples of such basic SI units include as illustrated in the table below. So we have the quantity and the unit of measure. The first quantity is the mass, which is normally measured in kilograms. Then we have time, which is measured in seconds. Distance, which is measured in meters. The current, which is being measured by the amperes. We also have the other basic SI units, that is the amount of substance. Amount of substance is normally measured in moles. The luminous intensity is measured in candela. And finally, we have the thermodynamic temperature, which is measured in Kelvin. Then after the basic SI units, we have the derived units. These are obtained through either multiplication or division of the basic SI units. Examples of derived units include area, volume and density. The three are derived from distance. We also have force, power and energy. Just to test our understanding, can I have an example of a derived unit from one of the members? Example of one. Yes, we have area. Any other example? Velocity, very correct. That is derived from distance and time. Do you have any other example? Okay, that is all for that point. Density, that is correct. Now we want now to start dealing with these derived units one by one, and the first one is force. We normally define force as a push or a pull on an object, and the unit of measuring force is the Newton. Examples of forces: we have gravitational force, kinetic force. Can we have any other example from the trainees? Examples of forces: any other type of force? Divina. Upthrust force, that is correct. Joseph, any other type? Kinetic force, correct. Any other type of force? Okay. Types of forces. We also have forces like weight. Weight is also a force because it is a force which is acting directly to the center of the earth. Then another example of derived unit is the work. If you want to define the work, then you normally define it as the measure of energy transfer that occurs when an object is moved over a distance by an external force. So from the work we can see that we have one basic SI unit, that is the distance in meters. We also have the force. The force is also derived from the basic SI unit. So if you want to get work, then we normally take the force and we multiply it by the distance. Force in newtons and distance in meters. So the unit for measuring work is the joule, capital symbolized by capital J. The next derived unit we want to see is the power. And how do we define power, Divina? What is the definition? Correct. Power is normally defined as the rate of doing work or the rate of conversion of energy. So for this derived unit, we are having time, the rate. From the rate, we have time, and the time is the basic SI unit. And from work, work was derived from the basic unit distance and the derived unit force. So the unit of measuring power is the watt, to brackets capital W. Mathematically, we can express power as the amount of work or the rate of energy converted divided by the time in seconds. So the unit for work is the joule, the unit for time is the second. So we take power is equals to work divided by time. Another derived unit we are going to handle today is the charge. Remember, we learned about charge during our last lesson, and we defined charge. How did we define charge, Joseph? Charge, how do we define charge? Maybe another training to assist Joseph. Very correct. Thank you for that response. Charge refers to the physical property. So remember, charge can either be positive or negative. So if you have a negative or positive charge and we place it in an electromagnetic field, then that charge will experience some force. And that force, as we saw during the last lesson, is normally related by the Coulomb's law. The unit of measuring charge is the Coulomb. If you want to determine the charge, you normally measure it in the unit of Coulomb. For today, I want to leave you with one assignment, which will be to explain 5 other derived units which are normally used in engineering. So explain any other 5 derived units in engineering. That will be the end of our lesson for today. Do we have any question? Okay, correct. Meet next time. Okay.
Yes.